Welcome back, guys. This is question 2.34 and the statement of this question is consider the circuit shown in figure 2.34. So this is the figure. In this figure we have to find I naught. Okay, so this is I naught here, and also the part B of it is verify that the values of I naught by showing that the power generated in the circuit equals the power absorbed in the circuit. Okay, so here we have this circuit. First of all, in part A we have to find the value of I naught. This is a loop, while this one is another loop. Here we have this source, which is of this diamond shaped voltage source, which is the dependent source, and it depends upon this V1, which is here across this 4 kilo ohm resistor. Okay, so let us first find the equation here, that how can we find out the value of I naught. So here applying the KVL and then finalizing the output, the output here is I naught is voltage divided by the total resistance. So the total voltage divided by the total resistance, okay, or the equivalent resistance. Here we can see that these two resistors are in series because the same current is flowing through them. So therefore in series the two resistors will be added together. So therefore 6 plus 2 is 8. So we have 8 kilo ohm, and also the voltage, the total voltage here is V1 by 2. So therefore it is V1 by 2. Okay, so this is equation number A, and here we don't know the value of V1. Okay, while this one is the V1. Now in order to find the value of V1, we can see that here the current is flowing, and the value of this current provided by this source is 10 milliamps. Okay, so therefore this V1 is basically 4 kilo ohm, and that is V1, which is the voltage across this 4 kilo ohm resistor. So therefore according to the Ohm's law, it will be I into R. The value of I is 10 milliamperes, which is 10 into 10 to the power minus 3, and the value of R is 4 kilo ohm. So 4 multiplied by 10 to the power 3, these two will cancel out, and here the value of V1 will be 40 volts. Okay, this is equation B. Now take B and put it in A. What will I get? The value of I naught will be equal to, that would be 40 divided by 2 divided by 8k. So it will be 20 divided by 8k, or it is 4 5 20 and 4 2 8, and also 2.5 milliamps. Okay, so the value of I naught is 2.5 milliamps, and we have found it out. Now in part B of my question is verify that the value of I naught by showing that the total power generated in the circuit equals the total power absorbed. Okay, so the power generated in the circuit is by this source and this source. So this is, let me call it PG, and we have to find PG1 plus PG2. Okay, this is the PG1 and this is PG2, as this is a source, and in order to find the power across any source or the power generated by any source, we have to multiply the voltage across it, multiplying it with the current which it generates. Okay, so that is P equal to IV. For this PG1 we have a current 10 milliamps. Okay, and the voltage is V1 because these two are in parallel. So therefore that is 40 multiplied by 10 milli. Okay, or it can be 10 into 10 to the power minus 3. So it will be 400 into 10 to the power minus 3. So it will be 0.4 watts. And also PG2, which is this one, it is the voltage which is V1 by 2. So V1 by 2 is 20 multiplied by the current which is I naught. So I naught is 2.5 into 10 to the power minus 3. Okay, let me find it out. So it will be 2.5 multiplied by 2 is 5, and multiplied by 10 is 50. 50 into 10 to the power minus 3. Okay, or it will be 0.05 watt. Okay, so let me add them together here. So it will be 0.4 plus 0.05, so it will be 0.5 0.45 watts, which is the power generated. Now in order to find the power consumed here, that will be the power which is consumed, that is C, that will be the power generated by consumed across 4 kilo ohm resistor plus power consumed by the 2 kilo ohm resistor plus the power consumed by the 6 kilo ohm resistor. This is 4K, this is 2K, this is 6K. Okay. Now in order to find them out, as these are basically the passive elements, so therefore P will be equal to I square into R. Okay. So therefore now for 4K, if I want to find out the power for 4K, the current through it is 10 milliamps. So 10 into 10 to the power minus 3 square into 4K. So 4 into 10 to the power 3. Okay. Or it will be 10 to the power minus 4 into 4 into 10 to the power 3. So it will be 0.4 watts. Okay. You can calculate it and you will see that it will be 0.4 watts. Now in order to find the value across or the power consumed by this 2K ohm resistor, so it will be 2K and the current through it is I naught. I naught is also found out, and that is 2.5. 2.5 into 10 to the power minus 3 whole square multiplied by the 2K. So therefore 2 into 10 to the power 2 into 10 to the power 3. So here we will get 2.5 square multiplied by 10 to the power minus 3. So how much would it be? Let me find it out. So 2.5 square, this is 6.25 into 10 to the power minus 6 into 2 into 10 to the power 3. Okay. So multiplying it, it will be 6.2. Let me find it out here as well. 6.25 multiplied by 2. So this is 12.5 into 10 to the power minus 3. Okay. Or finding it out again, 12.5 divided by 1000, sorry, it will be 0.0125. 0.0125. This is for the second one. Now for this third one, we have to do what? We have to use the similar one, but we have here, instead of 2 we will have here 6. Okay. So let me put here this 6. What will I get? Let me again calculate it. Okay. So here 6.25 multiplied by what? That is 6. Okay. So this is here 6 and dividing it over 1000. This is now 0.0375. So this is 0.0375. Let me add all of them together. What will I get? So here it will be plus 0.0125 and this one, and plus 0.4, it will be 0.45. Okay, because I have added this one and this one together, and I have got here 0.45, and that is what you can see, that the value of the power generated is equal to the power consumed, and that is what we were looking for. Okay. So that's it for today, in which we have seen the solution of question 2.34. If you guys have any question, you can ask me in the comment box. See you soon.